Good morning, everyone. And for those that may not know my name is Yvonne Malooly, and I'm the Assistant Chief Executive with responsibility for the chemicals area within the authority. So this morning's webinar is being recorded, and if you have any questions throughout the webinar, then I put them into the question and answer function, and we will address those at the very end. So this morning, I'm delighted, of course, to welcome you all to this webinar on technical land use planning for developments on or near COMAH establishments, following the publication of our recent guidance. The new guidance actually interprets the authority's policy on technical land use planning advice under the Seveso III directive, as it is implemented by our 2015 COMAH regulations. The new guidance obviously replaces the 2010 policy and approach guidance that was previously there, and this new guidance has a greater emphasis on more rigorous risk-based approach across all sectors in relation to the provision of technical land use planning advice. This morning you will hear from two of our inspectors, Pat Keneally, who is the Senior Inspector, and Ita Daly. So both of those are working within the COMAH unit within the authority. Ita will cover parts 1 and Pat will cover parts 2 and 3. So I'll pass you over now to Ita.
So thank you to Yvonne for the introductions, and good morning, everyone. I too would like to welcome you all to this webinar on our recently launched guidance on technical land use planning. And as Yvonne mentioned, this webinar is being recorded, so it will be available on the authority's website in due course for any of your colleagues who are unable to join us this morning. We will have time to answer your questions at the end of the presentations, and these can be submitted using the Q&A function at the bottom right of your screen. Just by way of introduction, my name is Ita Daly, and I'm an inspector in the COMAH unit based here in the Cork office, as well as carrying out inspections and other COMAH regulatory duties such as safety report and notification assessment. My colleagues and I are also tasked with providing technical advice in response to requests submitted to us by planning bodies for proposed development on or in the vicinity of a COMAH site. I'm going to cover that in a little bit more detail and how that relates back to you as a COMAH site operator. But first, let's look at the requirement for how land use planning came about. So in the 1970s, the chemical industry was experiencing a period of exponential growth, and the primary focus of most companies was to develop advanced chemical processes to fulfill the demand for new materials following the scientific technical revolution that began after the Second World War. So there were a number of catastrophic industrial accidents as a result of this record growth in the chemicals industry, and one of those was an explosion at a chemical plant in Flixborough in the UK, killing 28 people and injuring 36 on the site. There were 55 off-site injuries, and up to 2,000 homes and businesses in the vicinity suffered significant structural damage. In 1976, at a chemical plant near a town called Seveso in Italy, a dense vapor cloud containing dioxin, which is both poisonous and carcinogenic, was released, resulting in more than 2,000 people being treated for dioxin poisoning and the contamination of 10 square miles of land and vegetation. Events such as both of these incidents prompted the adoption of legislation on the prevention and control of such accidents in Europe, and hence came the so-called Seveso I directive. The Seveso I directive was then amended in view of the lessons learned from later accidents, such as in Bhopal and Mexico City, and this brought about the Seveso II directive, which introduced new requirements for land use planning. Most recently, the Seveso III directive was adopted, and this took account of lessons learned from accidents such as in Toulouse and Buncefield. So in Ireland, the COMAH, or the Seveso III directive, is implemented by the Chemicals Act Control of Major Accident Hazards Involving Dangerous Substances Regulations, or COMAH regulations, in 2015, and it applies to about 100 establishments, which, apart from a concentration in Cork and Dublin, are generally spread throughout the country, as you can see from the map here. So what are the land use planning requirements that apply to all these sites? So the protection of residential and other populated areas likely to be affected by a major accident is a key aim of the Seveso directive. It also covers the safeguarding of environmental receptors. So the directive sets out that member states should ensure that the objectives of preventing major accidents and limiting consequences of such accidents are taken account into their land use policies. And these objectives should be pursued through controls on 3 separate types of development. So firstly, the siting and development of new establishments, then modifications to existing establishments, and finally development in the vicinity of establishments. And in applying these controls, account must be taken of the long-term requirement to maintain appropriate distances between establishments. And you can see the list here: residential areas, buildings and areas of public use, major transport routes and recreational areas, and areas of particular natural sensitivity or interest. So as I mentioned, and as set out in the new guidance document, the Seveso directive is primarily implemented under the COMAH regulations of 2015, and the land use planning requirements of the directive are addressed by Regulation 24. In addition to the COMAH regulations, the planning and development regulations also play a part in the implementation of the directive. So let's now look at the roles of both the HSA and the planning bodies. I spoke about the directive requiring appropriate distances between establishments and certain receptors. So it requires the HSA to set and review a distance around each establishment, and this is called the consultation distance. Now, what do we mean by consultation distance? Well, in essence, it's a protective zone around a COMAH establishment to ensure the risk to human health and the environment is minimised, especially for the developments I outlined already. So residential areas, buildings and areas of public use, recreational areas, and so on. And once this consultation distance is set for an establishment, it then must be formally communicated to all relevant planning bodies. In 2021, the consultation distances for all establishments were reviewed and updated, and details of the revised consultation distances were sent to the relevant planning authorities and to site operators in the form of a GIS file. So here is an example of what those mapping files look like overlaid in a map. This is an area with multiple COMAH sites. So the consultation distance is generated using the risk-based approach described in the new guidance document, and it corresponds to a 1 by 10 to the minus 9 or 1 in a billion fatality risk contour. It is important to point out that this risk figure is based on the inventory provided in your COMAH notification. Therefore, if there are modifications on a COMAH site, including changes to the quantity of dangerous substances, it is vital that these modifications are communicated to the authority through the significant modification process. Now, once a planning body have been informed of the consultation distance around a site, they then in turn are required to seek technical advice from the HSA for certain types of proposed development within the consultation distance. These types of proposed development are set out in the planning and development regulations, and they range from the provision of housing to schools, hospitals and creches to commercial, industrial or office development for 20 or more employees. And as well as new developments, the requirement for technical advice also extends to new development on a COMAH site or for permission for a new COMAH establishment. European best practice advises that a technical land use planning advice system should apply the principles of consistency, so the outcomes from broadly similar situations are broadly the same under similar conditions. Proportionality, so again, the constraint should be proportional to the level of risk. And lastly, transparency, so an understandable, clear and well-described decision-making process should exist. Best practice also requires that account be taken of the most recent technical knowledge. The system set out in the new guidance document adheres to these principles and also takes account of recent publications at an EU level, along with taking account of any relevant technical knowledge in the provision of technical land use planning advice. So just to cover, now that we know the process around how land use planning is managed, I want to cover how the technical advice is formed and provided to the planning authorities when requested. So first, let's look at new establishments. So this covers the siting and development of newly constructed COMAH establishments, but it also includes sites of existing operation where the COMAH regulations did not previously apply, but now such a site intends on increasing their inventory of dangerous substances above the COMAH thresholds and thereby bringing them within the scope of the COMAH regulations. In keeping with the longer-term aims for land use planning under the Seveso directive, technical advice in relation to new COMAH establishments will be more stringent than that which applies to existing COMAH establishments. The individual location-based risk contours for new establishments are not to be exceeded are set out here on the slide. So you can see that the maximum tolerable risk to a member of the public should not exceed 1 by 10 to the minus 6 per year, and the maximum tolerable risk to a person at an off-site work location should not exceed 5 by 10 to the minus 6 per year. However, even if these individual risk criteria are met for a specific development, a societal risk evaluation may also be necessary. And I'll cover societal risk in more detail in a moment. So in addition to the advice given to planning bodies on a new establishment may also include an advisory to consult with the principal response agencies in relation to emergency planning and response arrangements. So moving on to advice on significant modifications to an establishment. As you are aware, the authority have already published guidance on significant modifications in 2019. In summary, the HSA regulates the on-site risk element, setting limits for the tolerable level of risk increase that will be permitted, and then generally requiring the lowest level of increased risk through the use of additional technical measures. But for off-site risk, the referral trigger is an off-site location fatality risk equal to or greater than 1 by 10 to the minus 6 per year, and it will then be referred to the planning authority. The HSA must always be notified by operators in advance of any planned significant modification, and the procedures outlined in the guidance on significant modifications under the COMAH regulations must be followed, irrespective of whether or not a modification will be subject to a planning application. And we will use the data and documentation submitted in the significant modification process when providing technical advice to a planning authority. For development in the vicinity of an establishment, which is within the consultation distance, 3 zones of risk are plotted around the establishment. These 3 zones are based on the location, quantity, and hazards of the dangerous substances present on the COMAH site, and this is based on the information submitted in your COMAH notification. The zones are inner or zone 1, middle or zone 2, outer or zone 3, and you can see the risk figures for each of the zones, with the inner being the most restrictive at 1 by 10 to the minus 5, extending to 1 by 10 to the minus 7 for the outer zone. To give you an idea of what these risk zones look like, here on the map is a fictitious COMAH site with the 3 risk zones overlaid. You can see that the inner zone with the red contour is the one closest to the site boundary. And occasionally, depending on the nature and quantity of the dangerous substances, the inner zone may not extend outside the south boundary. The middle zone then is sits outside the inner, is the orange contour, and the outer zone is the green contour. So associated with each of these 3 zones are 4 levels of development. And these levels are set out here in the top table on the left, with level 1 being the least sensitive, increasing to level 4 for very large or sensitive development. The full text of the development sensitivity levels are set out in Appendix 2 of the new guidance document, but just to give you a general sense, Level 1 covers people at work and parking areas. Level 2 is for development for use by the general public, such as housing, hotels and transport links. Level 3 covers development for use by vulnerable people like hospitals, schools and creches, sheltered housing, nursing homes. And level 4 then is for very large and sensitive developments, things like larger scale hospitals and education settings, and very large outdoor public use spaces such as theme parks, sports stadia, and so on. So when the sensitivity level of the development has been determined along with the location within either zone 1, 2 or 3, then the table on the bottom right of the slide here gives an indication of what the authority's advice would be to the planning authority. You can see that sensitivity level 1 development would not be advised against in any of the 3 zones, but sensitivity level 4 would be advised against in all 3 of the zones. So this system is based on individual risk. So that is the risk to a person permanently located outside the establishment. However, there are times where the risk of multiple fatalities from an accident or societal risk should be taken into account more explicitly. For example, this may include where a planning application relates to a proposed significant off-site development, with significant population density, or where there is already a significant population residing or working within the risk zone, or where the risk is emanating from more than one establishment. So to take account of societal risk in such situations, we will initially obtain an estimate of the expectation value. And the expectation value is a multiplication of accident frequency expressed in chances per million and the number of people suffering a fatality in that accident. Societal risk is covered in more detail in section 1.7 of the new guidance, and in general, the expectation value should not exceed 10,000. If it does, the advice to the planning authority would be always to advise against the development. Especially large-scale or sensitive development within the consultation distance will likely require societal risk evaluation, and the societal risk criterion is applied in addition to the individual risk criteria we previously outlined. Just to touch on the environmental aspects, in the context of land use planning, the prevention of MATIs will be the primary objective, and it is expected that accident pathways will be prevented. Where this is not practicable, or in the context of significant modifications at existing COMAH establishments, the assessment of major accidents to the environment focuses on the specific risks to sensitive receptors within the local environment, the extent of consequences to such receptors, and then the ability of such receptors to recover. So environmental damage may be relatively long-lasting, but it is not necessarily irreversible. So the recovery of habitats within a reasonable period of time is possible, and depending on the dangerous substance involved, and this information then can be weighed up when providing advice. The full detail relating to land use planning and the environment is contained within section 1.8 of the new guidance document. Just to touch on the public information zone. So prior to the COMAH regulations of 2015, the specified area was defined as an area at greater risk of being affected by a major accident, and within which an upper tier establishment had to supply information directly to persons in that area on the appropriate action to take in an emergency. So whilst this area still exists, it is no longer referred to as the specified area. The requirement is to provide this information. The requirement to provide this information still applies under the 2015 COMAH regulations, but this area is now to be known as the public information zone. So this zone will, at a minimum, coincide with the outer land use planning zone. And the HSA will use its discretion as to whether it should be enlarged further based on the consequences of the identified major accident scenarios for the site. So existing specified areas will continue in use as the public information zone until they are replaced, which will happen as generic land use planning advice for each establishment is rolled out to planning authorities. And that leads me on to my last slide now, covering the development of such generic advice. So the authority plans on preparing generic land use planning advice for all COMAH establishments. This generic advice will be based on the data provided in your COMAH notification and will include development of the 3 risk contours for inner, middle and outer zones I described earlier. Once completed, this generic advice will then be provided to the relevant planning bodies. Due to the nature and volume of the task, the authority is seeking external technical expertise to develop this advice for each establishment subject to the regulations. The tender process is ongoing and we don't really have a timeline as to when the work will commence as yet, but it will be a multi-year project. The charging of fees for services under COMAH is covered by Regulation 27 of the COMAH regulations, and it sets out the activities for which the authority may charge fees, and one of those is the provision of technical land use planning advice. So this will be a chargeable activity, and as set out in the scale of fees of January 1st, 2016, the initial fee will be €3,000 covering the first 5 days, up to a maximum of 20 days at €600 additional per day. And further information on charging is available on the COMAH pages of the authority's website. So that brings me to the end of my section. So for now, I'm going to hand you over to Pat, and he's going to take you through some of the more technical elements of the new guidance document. Thanks, Pat.
Thanks, Isa. Hello and welcome to the second part of this webinar, and I'm going to deal with parts 2 and 3 of our new guidance on technical land use planning advice, which we just launched in January of this year. I'm Pat Keneally. I'm head of the COMAH unit, which is responsibility in this area. And as Isa mentioned, it's if you have questions, it's probably best to hold them till the end. Certainly make a note of them, but we'll try and deal with them at the end. And if perhaps even you'll find your question has been answered before we get to the end. So hopefully that will be the case. Okay, so there we go. So the guidance sets out in considerable detail how the authority will develop generic advice for planning authorities around COMAH establishments. And as Isa said, we intend to roll that out over the next few years. The guidance also contains advice for planners on how to interpret that technical guidance. And we covered that in a previous webinar. So if you're interested in that aspect of it, you should look that up. Now, Isa has brought you through part 1 of the guidance, and I will now give you an overview of parts 2 and 3. And I'll particularly emphasize and highlight where we have made changes. Parts 2 and 3 are quite technical. Part 2 sets out the technical underpinning of the method, while part 3 describes how it will be applied in the different sectors. Of course, again, reiterating what Isa has said, the ultimate aim of all this is to provide 3 generic advice contours around each COMAH establishment, and that will be supplied to the planning authorities, and they can use that then for the future control of development around those sites. Now, a key element of the approach is the estimation of the consequences of exposure to a hazardous agent. The method employed relies on the use of Probit Equations to address this question, and here are 3 Probit Equations. The first is for chlorine toxicity, and the Probit provides a lethality value for exposure to chlorine gas. And it depends on the exposure concentration, which is C in the equation, and T, the exposure time in minutes. And as you can see in that equation, the concentration has a big impact on the Probit value. The second Probit is for fatality from exposure to thermal radiation. The heat intensity is represented by I, and the duration of exposure, which in this equation is in seconds, is represented by T. The final Probit is for fatality from overpressure. Here, the value depends only on the intensity of the overpressure, and there is no time effect on that. So the utility of these Probit functions and values is that we can obtain from specific exposure scenarios, we can obtain values that can be translated to fraction of fatality experienced in an exposed population. And this is really useful when trying to convert estimated exposure consequences to a risk of fatality, which is required to generate the land use planning risk contours. The Probit for used for thermal radiation effects on people was derived by Eisenberg in 1975. Most of the probits used in the method have been obtained from the Dutch National Institute of Public Information and the Environment, and that's RIVN for short in Dutch, and that's the reference manual of BEVI risk assessments. BEVI refers to Public Safety of Establishments Decree, so it's similar to our own COMAH regulations. And it describes the approach to such risk assessment in the Netherlands, and we have drawn heavily on that for our own guidance, as we have on the approach of the UK HSE, particularly in relation to the matrix of advice and in developing our overall method. So one of the more notable changes that we've made in the revised guidance is to change the standard exposure time to pool fire radiation from 75 seconds down to 60 seconds. The same Probit is used as was previously used, but the assumed exposure time has been reduced. The previous exposure time was considered to be overly conservative when compared with both the UK HSE and the Dutch approaches. Now that does have knock-on effects on the levels that might be used for consequence modelling, as shown here, because they have increased. So for 1%, it's from 6.8 kilowatts per metre squared up to 8. For 10%, it goes up to 10.9. And for 50%, it goes to 15.9. Of course, thermal effects are mitigated by the shielding effects of being within a building separated from the source. The values used in that context are unchanged from the previous version, and generally exposure duration is not an issue for these endpoints. So if I go to look at overpressure now and the Probit for that, we can see that when it comes to overpressure from explosive events, The approach is the same as in the previous version, and the same probit is used. For vapor cloud explosions, or VCEs, the standard model makes the assumption that 20% of the stoichiometric cloud volume is in the confined area, and that's provided there is some confinement present. If the confined volume is known to be greater, then that volume is used. And it will be modelled at strength 7 using the TNO method, while the remaining unconfined cloud will be modelled at strength 2. So here are some landmark overpressure levels with associated fatality levels, and they're all unchanged from the previous version. When it comes to protection or lack of afforded by buildings, the Chemical Industries Association approach is followed as it was in the previous version. Typically for residential buildings, the value from CIA curve 3 is used to derive fatality levels within buildings. The graph included in the guidance also includes curves from the American Petroleum Institute. So the methodology there is to look up the overpressure along the x-axis and until the point it hits the curve, and then to go across and meet the fatality fraction on the y-axis. It is also intended to provide some consequence advice to planning authorities along with the risk contours that are provided in the generic advice. So for damage to buildings from overpressure, some of these contours could be included, most likely for glass breakage or light to moderate damage, for very unlikely, and therefore they'd be outside the standard contours, but still possible accidents. Because it's important we feel that the planning authorities are fully apprised of the consequences of the major accidents, as well as the risk. So an updated table of probits has been included in the guidance. As you can see, most are from the Dutch publication that I previously referenced. A couple are also included there from FAST, and those came from our expert group. And that gives me an opportunity to thank the expert group for sharing their knowledge and time and providing input in the earlier stages of the development of the guidance over a couple of half days in late 2019. And of course, in that context, the draft guidance went out to public consultation earlier in 2021. And we received a lot of constructive feedback at that point, and most of which we have tried to incorporate into the guidance, but more on that later. Now, part 2 of the guidance also contains some other important modelling parameters to be used in the standard model. Modelling temperatures are now specified at 15 degrees for daytime conditions and 10 degrees for nighttime conditions, so that's new. Atmospheric stability conditions are specified as D5 for 80% of the time and F2 for the remaining 20%, so that's as before. Wind direction is accounted for by taking account of the nearest weather station and using an 8-sector probability fraction. In the standard model, receptors are assumed to be indoor for 90% of the time, so 10% outdoors as before. Being indoors will, in most situations, offer protection. Local terrain will also be accounted for with the surface roughness of 0.1 used by default. Now, in the provision of land use planning contours, environmental effects are actually not usually relevant, certainly not for existing establishments. In relation to the siting of new establishments concerning the environment, the emphasis is always on preventative measures, usually around containment, but separation distances could also be relevant. In this context, the toxic endpoints for humans may be sufficient, but sometimes a more sensitive endpoint may be necessary. The choice of endpoint will depend on the data that may be available, and sometimes surrogates would have to be employed. When examining environmental contexts, damage and consequences in this context, damage duration and receptor resilience are also factored in. In modelling, pool size is also an important factor because these will influence the evaporation rate and also for flame height calculations for pool fires. The maximum diameter used for a pool will be 100 meters, provided that area is available. If physical restrictions mean that only a smaller size is possible, then that will be used. Another point I should make here is that bund overtopping pools may not always be possible due to a lack of space. And as you can see there in the second drawing I have there, a pool cannot form on one side due to the presence of some sort of building or a wall. And in these circumstances, the probability of an overtopping pool is just distributed over 3 pool locations instead of 4. So each of the 3 become a little more probable, but there are only 3 locations for the modelling. A fresh approach has been taken for estimating thermal radiation from pool fires. In the 2010 document, values for surface emissive power of flames for surrogate Class 1 and Class 2 flammable liquids have been included. The current guidance does not include those, so that's an important change. It does include a table of maximum surface emitted powers for a variety of common flammable liquids. However, these values are maximum values, and some attenuation is necessary when estimating the flux experienced at a receptor. The preferred standard consequence model approach is to use a 2-zone flame model to take account of smoke obscuration, which typically occurs in an upper zone. The distance to the receptor and the view factor to each flame zone is taken into account, as is the atmospheric transmittance. So this will yield a more realistic thermal radiation level, which would be calculated on a case-by-case basis. Flammable liquid classification now follows the classification, packaging and labeling regulation approach. And a bridge graphic from ECHA's CLP guidance is included in our guidance so that the clear links between flash point and boiling point and flammable classification are clear. But as I say, it's flammable liquid categories 1, 2, and 3 that are followed here. Now, in our experience, ignition probability has been the source of dispute in land use planning advice area and contention. So the guidance now includes ignition probabilities for use in the standard model. Excuse me. So as you can see there, the flammable liquid categories are assigned to an ignition category, from 0 to 3 as shown in this graphic. So for flammable categories 3 and for 2, that's relatively straightforward. It's a straightforward mapping. But for flammable category 1, there's a subdivision there into 2 ignition categories, and the substances that have the lowest flash point go into an ignition category 0. So this leads on to the assignment of ignition probabilities, and as you can see from this table, ignition is assumed to be either immediate or delayed. Class 0 high reactivity refers to the most flammable of gases. Class 0 low reactivity refers to gases like methane, and also is being used for ignition 0 flammable liquids. And then we have the other flammable liquids as shown. And by the time we get down to category 3 flammable liquids, it means that the ignition probability is 0. So this is quite a change from the methodology that was in the previous version of the guidance, and allows a lot more discrimination in relation to the type of flammable liquids that are stored on the site. And we've also included values that specifically relate to transport units, as you can see there, again using a similar type of methodology. And also ignition probabilities specifically for flammable releases at jetties, for example. That's also the first time that's appeared in the guidance. So a very comprehensive list of ignition probabilities is provided. As you will shortly see, the delayed ignition probability refers to the delayed ignition branch of an event tree. But an allowance is sometimes made that some sub-branches will not result in fire or explosion. So it doesn't definitely mean that there will be an explosion event consequent on that. And that's in line with the approach in the bevy itself, and also the methodology used in the Flemish region of Belgium, which is widely, admired and followed elsewhere. So hopefully this will all become clear when I look at event trees a bit later on. So briefly now, if I might just pause there, I've come to the end of my overview on part 2 of the guidance, and we've set out the approach to land use planning. It's fatality based, and so I've tried to pin down there in part 2 the values of the variables that the variables will take in deriving that, so to ensure that a consistent approach is taken erring on the conservative side. The guidance sets out the standard approach the HSA will take in deriving generic land use planning contours for planning authorities. So the final piece now is to identify the appropriate scenarios and their likelihood. And that's what part 3 of the guidance does. So I will try to highlight the approach taken without going into every detail. Obviously, it's an extremely detailed document, and this part in particular is detailed. There's over 200 scenarios listed in part 3. So I'll point out where the more important changes have been made. For this part, inspiration has been taken from the bevy with some tweaks here and there. And I want to emphasize this will be the standard approach to generating generic contours around existing establishments for planning authorities, and does not preclude a more specific QRA in the appropriate circumstances. Such QRAs should use coherent and consistent data. The authority exercises absolute discretion in deciding whether to accept such data. So the first sector that I want to have a look at is LPG, and I will use it to illustrate the general approach. There's an inventory shown there, which is from the bevy, and before that it appeared in the purple book, and it's for an instantaneous release of flammable gas. And you can see the sub-branches for immediate and delayed ignition, and you note also that some branches could result in no effects from delayed ignition. So the nuts and bolts then. Here is the inventory that was populated for that instantaneous release scenario. You can see the ignition probabilities for the various branches, and that some end with no effect. LPG is highly flammable, and so is in ignition category 0 high reactivity. That means an immediate ignition probability of 70% and a delayed probability of 30%. And at the bottom of the slide there, you can see that how that inventory information has been transformed into part of table 23. And you can see the full table here, and the data from that is taken from 3 such inventories. Now, a similar approach yielded the tables for the other scenarios. For the 10 millimeter scenario, which is highlighted in orange in the first table, that means that those scenarios may only be relevant close to the establishment boundary. And you will see that approach taken in some other tables. So we made these and other changes following the public consultation, where we received comments that there were too many scenarios and requesting that we just try to reduce the number. The second table there was for road transport units, and we also have included now a table for loading arms, and finally for jetty operations. So it's a very comprehensive coverage for this sector now that will specify how the modelling is to be done in the standard case. Another point to note for the sector is that explicit allowance is made for buried or mounded vessels and the reduction in levy likelihood. You can see that the table for buried vessels no longer includes a levy frequency, just a fireball frequency. The levy frequency now leads to no effect. That's not shown in the table because I wanted to emphasize the comparison with the standard vessels in the table above it. But it should be added in to tally up with the frequency of the scenario. So I'll push on now to the LNG sector, which is new and developing. And again, it's a new sector in our guidance. And again, using inventories and the ignition probabilities in part 2 of the guidance, similar tables were obtained for this sector. Now, because of the potential release conditions for LNG, it's stored typically at minus 160 degrees Celsius and may or may not be under significant pressure, and that will vary depending on how it's going to be used. So pool fire frequencies are greater than for LPG and levy frequencies are less. This section of the guidance is directed at smaller scale use of LNG because we have encountered a number of those arrangements at existing energy consumers and suppliers. But it doesn't cover larger facilities, particularly floating gas, floating storage regasification units, floating storage units, FSUs, and the like. So it's very much geared for the typical user or possibly supplier arrangement that we find at the moment. So we'll move on again to another sector, which is for RNG. RNG stands for Renewable or Recovered Natural Gas. And this is another sector which is included for the first time in the guidance. Now, there's not a whole lot out there to help in drawing up the tables for this. Because RNG is produced under low pressure, it was considered that fireball followed by fire would be more credible than a levy event, for example. And for continuous releases, jet fires were considered to have some probability. Once purified, the recovered gas is pressurized into drums or cylinders. So that is also addressed for the sector, as you can see from the second table there. Hydrogen sector has also been added for the first time, and it's really in there as a placeholder at the moment until we see how the technology develop. Hydrogen is a flammable pressurized gas, so the scenarios for flammable gases and for drums and cylinders in other sectors will be relevant and can be drawn on if more specific data is not available. But the guidance is intended that the guidance will be updated once the technologies become clearer. So I'll turn now to flammable liquid storage installations. You saw in part 2 of the guidance that there is now much greater discrimination between the different categories of flammable liquid, and that's also very apparent in part 3. This is the base of entry from the bevy, which is then modified to take account of the ignition probabilities of the different categories of flammable liquids. You can see here tables for liquids with low boiling points and very low flash points, which are characterized as ignition category 0 liquids in the guidance. As you would expect, the full panoply of consequences, pool fire, vapor cloud explosion, and flash fire are included for this category. Lines not resulting in ignition events are described as toxic or none, and that differentiates from the low reactivity flammable gases that fall into the same ignition category. For other flammable liquids category 1 that fall into ignition category 1, those events are less probable, and more emphasis is also given to the potential for MATI events. Second table, sorry, yep, I moved on there. So by the time we reach ignition category 2, then we're just modeling pool fires. And of course, they're at a reduced frequency. And we also include the potential for toxic or MATI events as well. And then when we move on to ignition category 3 liquids, fire and explosion events are not relevant unless they are co-located with the more flammable liquids. So again, that's quite a big change from the existing guidance. Another innovation for this sector is the provision of detailed loss of containment scenarios for road transport units at an establishment. Again, modelled events and frequency depends on the flammable and ignition categories. So I'll just take you through now the derivation of the tables for some road transport units. So we started with the basic bevy event tree and used the ignition probabilities for road transport units in part 2 of the guidance. And we also make allowance that there's probability that some events will not result in fire or explosion. I also want to point out something else on this tree. You recall I mentioned previously that following the public consultation, we made an effort to reduce scenarios where we could. So, for example, we've done that here and maybe in lots of other trees as well, where we've combined early and late pool fire scenarios into a single scenario. So as you can see, the arrows there showing the total pool fire probability there is 4.36 by 10 to minus 6. So if you actually come in and just look at the tables and try to maybe reverse engineer them, you might find that the numbers don't add up, and that's the reason why that's the case. And again, just to illustrate the complexity involved in producing those simplified tables, let's look at the instantaneous failure of a tank containing flammable liquid category 1 and ignition category. 2 trees have to be considered here, one for the spill in the bund and one for the overtop event. This is the bond event tree. The ignition category 1 ignition probabilities are used. And as you can see, these have been reproduced in that part of the table then, describing the instantaneous failure event. And similarly, for the overtop event tree and the resulting table. So you can see there's a lot behind those simplified tables in the guidance. So now I'll just move on to the next sector, and that's the fertilizer sector. And there has been a significant enough consolidation of methods for this sector, and a single approach is specified. It's explicitly stated in the guidance that applies only to ammonium nitrate name substance 2 fertilizers, which is the type of fertilizer we usually encounter in Ireland. Model scenarios will be for fire and explosion on trucks and in the yard, stacks stored in the yard, and for bulk storage in warehouses. 300-ton detonation events are included, but they're at a very low frequency. For dangerous substances warehouse, there haven't been too many changes for that sector. One point to note is that now there is a clear allowance for frequency reduction for small and large warehouse fires where sprinklers are installed and operational. For process plants, a table of loss of containment events involving bulk storage of toxic liquids, which was absent in the previous revision, has now been added. Also, events involving road transport units have now been specifically included. And the approach to process vessels has been set out. The guidance recognises that releases may occur at elevated temperature and or pressure. A simplified approach ignores explicit consideration of the many sources of potential release, pipes, pumps, compressors, heat exchangers, and so on, and instead increases the frequency of releases from the process vessel. The loss of containment figure for a vessel can be multiplied by the number of active vessels in the reactor hall or building. And an increase in frequency is also made for vessels carrying out exothermic reactions. The storage and use of gas cylinders and drums has also been revamped. Differentiation is now made between cylinders, which are containers with a volume of less than 150 litres, and drums. Arrays of cylinders are now explicitly addressed, and conditional probabilities are set as shown there in table 63, which is included on the right. Ammonia refrigeration plant has been included for the first time. And given the different phases in the refrigeration process with high and low pressures and high and low temperatures, finding a simplified approach for the standard LUP model was not easy. But we did identify a reasonable approach, which is spelled out on this slide. And it involves an ammonia spill in pipework external to the building, so outdoors, at a temperature of minus 12 degrees Celsius, and with the maximum pool size possible of 100 meters diameter. And the probit then for the toxic would be taken from the toxic probit table that I referenced earlier, table 16, and that would be used then to establish the fatality levels in D5 and F2 conditions. Distilleries and spirit maturation warehouses are explicitly included for the first time as well in the guidance. The approach to modelling of ethanol fires is not firmly established. Recent publications, which you can see there, I've referenced, Swedish study and an ETAG safety executive research project as well, have indicated that the surface emissive power for ethanol is greater than for gasoline. And as it burns with a clear flame, the level of soot obscuration is probably minimal. So a high surface emissive power is assumed in the standard model. Now, on the other hand, allowance is made for aqueous solutions and cast strength whiskey, which are obviously much lower strength than 100% ethanol, and therefore that has to be factored in. On the other hand, warehouse fires are modelled conservatively due to the uncertain contribution of wooden casks. And, you know, again, we emphasize this is for the standard model. For QRAs, obviously a different approach could be taken, but we would require extensive justification for the use of lesser figures. Ethanol is a flammable liquid category 2 with ambient temperatures, and the bulk ethanol scenarios reflect that. So that's in table 66. However, ethanol is at elevated temperature in a still, and those scenarios are similar to a flammable category 1. So again, a simplification is applied, and loss of containment events for reboilers, pumps, condensers, and so on are reflected in the failure frequencies for the still loss of containment events, as can be seen in table 67. For warehouses, lower fire start frequencies are used, and that reflects the high level of security at these sites. And credit is also given for the use of sprinklers, but I should point out there's an error in that table, which should be, figure should refer to per year and not per hour. So I might step back now from all the technical detail and just to look at the bigger picture. The standard approach to be taken for the generation of technical land use planning contours for planning authorities has been set out in the guidance, and it does make a number of simplifications. And that ensures that a robust approach will be taken and the analysis will be carried out efficiently and at a reasonable cost. And as Isa mentioned already in her presentation, the costs will be borne by the operator as set out by the COMAH regulations of 2015. And we are tendering externally for this, and the tendering process has commenced. And when a successful tenderer is appointed, I think any kinks in the approach will be ironed out at that stage, if there are any in there. Part 3 of the guidance is amenable to technical change, and it's explicitly stated in there in the earlier part of the guidance that Part 3 can be changed without further recourse to the board. So it does allow us to make practical changes as we proceed. And if there are any inconsistencies, or as well as that, if new technologies develop, and we pointed out earlier in some of the sectors, we're still looking at the technologies that might come in and how that might be applied in Ireland. So they can all be incorporated in the future in a much simpler process, but shorter process too, hopefully. So in terms of the actual rollout of the generic advice to the planning authorities, as you said, it's difficult to say how long it's going to take, but certainly it would be nice to get it done in 3 years, and that would probably be on the optimistic end of the spectrum, but it could be up to 5 years. But I suppose given that land use planning provisions have been in place for more than 20 years now, and we still have had a lot of difficulty in rolling out, it's worthwhile, I think, now to try and get this done. And if it does take even a few years, at least at the end of that, it'll be done for all sites. So I'd like to wrap up this section with a few final words. I've emphasized at several points in my presentation that the guidance describes the standard approach. That is the approach the authority will take in developing generic technical land use planning contours that will be provided to planning authorities. Quantified risk assessments can be submitted by operators in relation to significant modifications or for new establishments, or by developers in support of development in the vicinity of such establishments. And such QRAs will be examined by the authority and may be accepted as representing a more accurate estimation of risk. But this will be at the discretion of the authority. So with that, I'll say thank you for your attention, and hopefully we can answer any questions you may have. So thank you.